Okay, we are going to draw a reaction pathway diagram, and we want the reactant's energy to start at 40 kilojoules per mole. We want to show a change in enthalpy of 15 kilojoules per mole, and we're going to have an activation energy of 50 kilojoules per mole. So starting with our reactants at 40, which is right here, let's go ahead. We're just going to use R for reactants. And we want to show a change in enthalpy overall at negative 15 kilojoules per mole. So we're going to go down 10, 15. So we're going to go to 25. And so our products are going to end right at 25 kilojoules per mole, about right there. So we're going to put in some activation energy here for our reactants, and we're going to put in an activation energy of 50 kilojoules per mole. Remember, that's 50 on top of the 40 that we're starting with. So 10, 20, 30, 40, 50. So our activation energy is going to go clear up to here. So we're going to put some activation energy in. We're going to form our activated complex up here, and then we're going to come down to our products. All right, so the product's energy is, we already said this, 25 kilojoules per mole. The activation energy for the reverse reaction. So let's tell you what, let's label a couple things on here so we get this straight. So our activation energy going forward was from here to here. So our activation energy, we said, was 50 kilojoules per mole. Kilojoules per mole. Now our delta H right here, label that on there, is negative 15 kilojoules per mole. So if we are looking at the reverse reaction, that means we're going that way. And so our activation energy would be from here, right there, all the way up here. So from 25 all the way up to 90. So that's going to give us a total of 65 kilojoules per mole. So remember, that's activation energy. I'm going to label it here. I'm going to label this, let's see, 65 kilojoules per mole. Let's label this activation energy reverse. R, there we go. And then it says, using a dotted line, show the curve of the same reaction with a catalyst. So we know what a catalyst does. We know a catalyst lowers the activation energy. So we're going to lower the activation energy. And we're just going to use a dotted line to show this. So really, this could look different for everybody. I'm going to show a really, really, really low activation energy. So adding a catalyst is going to lower my activation energy all the way down to there.